Hello everyone, good morning, good afternoon and good evening depending on where are you joining from. Today as a part of this webinar, we will be explaining why and where Knoldus Incorporation chose Rust as next programming language for software development. Knoldus is a team of passionate technologists with a product mindset who work along with businesses to deliver solutions at the speed of competitive advantage. Our main capabilities are around reactive products, IoT, microservices and API, data science, data engineering, and DevOps. We also have our strategic partnership with Databricks, Lightband, Confluent, and many more to deliver more values to client. So guys, my name is Ayush Mishra. I have also Pawan along with me. We are senior Rust developers at Knoldus Software. Most of the this talk is about Rust. Rust is a recently developed system programming language that is growing at a very steady pace. So without any further delay, let's take a look at the topic which we'll be covering in today's session. We will not be talking about coding. We will talk about what is Rust, why we decided to use Rust, and then we will move on and where we have used Rust. In order to pick any new language, there has to be some compelling reasons. In this session, we will talk about those reasons. Rust has many features that make it useful, but developers and their needs differ. We will explain in further slides. It is sponsored by Mozilla Research. Mozilla, basically Mozilla was the first investor for Rust and continues to sponsor the work of the open source project. Mozilla also utilizes Rust in many of its core initiatives, including Servo and key part of Firefox. Companies, large and small, are using Rust in production all over the world, including Mozilla, Dropbox, NPM, Postmates, Braintree, and others. Mozilla Research describes Rust as a system programming language that focuses on speed, memory safety, and parallelism. So moving on, Rust has been the most loved programming language in the Stack Overflow Developers Survey every year since 2016. As you can see in the screenshot, it is one of the most top 10 wanted language. Not only does provides a unique combination of performance and security, but it also empowers developers with the tool to start shipping their code faster. Moving on, it's a it's the one that runs blazingly fast and at the same time it prevents segmentation faults and runtime errors. A segmentation fault is the only one of the symptoms of an unsafe memory access. If you have dangling pointer that points to some unmapped memory and difference it, you will get a seg fault. A seg fault simply kills your program. Rust fixes segmentation fault using ownership feature. Ownership is a Rust secret weapon, a discipline for access control that system programmers try to follow, but the Rust compiler checks statically for you. It guarantees that your code is thread safe because it is safe by default. All memory accesses are checked. It is not possible to correct memory by accident. So Rust focuses on the speed, memory safety, and parallelism. Developers are using Rust to create a wide range of new software applications such as game engines, operating system, file system, browser components, and simulation engines for virtual reality. Rust is a statically and strongly typed programming language. Statically means that all types are known at compile time. Strongly means that these types are designed to make it harder to write incorrect programs. A successful compilation means you have a much better guarantee of correctness. So moving on to the next slide, let me explain why we decided to use Rust. As I mentioned earlier, in order to pick any new language, there have to be some compelling reasons. One of the biggest benefits of using a system programming language is the ability to control over low level details. The Rust compiler is stricter and makes sure you are using memory safety so that you can concentrate on the problem you are really trying to solve. You can concentrate only on business logic. Rust won't compile programs that attempt unsafe memory uses. Most memory errors are discovered when a program is running. Rust gives you the choice of storing data on the stack or on the heap and determines at compile time when memory is no longer needed and can be cleaned up. The main selling point of Rust is that it guarantees at compile time that your application will be safe from dereferencing null or dangling pointers. So how Rust does this? Rust does this through the concept of ownership and borrowing, that is enforced by a borrow checker at a compile time. This concept has three main rules. Each value in Rust has a variable that's called its owner. There can be only one owner at a time. When the owner goes out of the scope, the value will be dropped. Next feature of Rust is zero cost abstraction. If you are coming from C++, you should be aware of this term. Zero cost abstraction basically means no penalty for abstraction and only paying for the feature you actually use. So in Rust, we add abstractions without affecting runtime performance of the code. This improves code quality and readability without any runtime performance cost. You might not know actually, null was born more than a half century ago and it is still alive to create a mess for us, but not with Rust. Although Rust does not have null but provides an enum option that can encode the concept of value being present or absent. It has a very powerful compiler. As I mentioned earlier, the Rust compiler is stricter and make sure you are using memory safety so that you can concentrate on the problem you are really trying to solve. It checks each and every variable you use and every memory address you reference. It avoids possible data race conditions and informs you about undefined behavior. In Rust, you are explicitly forced by the compiler to write optimum memory safe code. The key feature of any modern programming language is package management tool. Like Scala has SBT, Java has Maven, Ruby has Gems, likewise Rust has Cargo. Cargo handles a lot of tasks like building code, downloading libraries or dependencies, and so on. It helps developers download and manage dependencies and assist in creating Rust packages. Packages in Rust are often called crates in the Rust community. Cargo is installed by default when you install Rust. Next feature is concurrency without data races. Handling concurrency safely and efficiently is one of the Rust main major goals. Concurrent programming is when different parts of a program execute independently. Initially, Rust team thought that ensuring memory safety and preventing concurrent programming are two separate challenges, but later on, team discovered that ownership and borrowing are two powerful tools to help and manage memory safety and concurrency problems at once. Many concurrency errors are actually compile time error in Rust rather than runtime error. So if your code is incorrect, Rust will refuse to compile so that you can fix it while you are working on it rather than after it has been shipped to production. So guys, due to time constraint, I won't be able to go in deeper. I would like to hand over to Pawan to explain where we have used Rust. Thank you.
Thank you, Ayush, for providing insights about Rust programming language. So these are the areas basically where we worked on by using Rust programming language. The first one is command line interface, the second one is networking, the third one is embedded. So hello everyone, Pawan this side. I'm a software consultant at Knoldus. So we have total 4 products in the areas like the first product is in the area of command line interface, the second product is in the networking area, and we have 2 products in the embedded one. So let's start with the first product, which is based on the command line interface, the Procespy. Procespy is basically a combination of 2 words. The first one is process and the second one is spy. It is a process monitoring tool for Linux distributions, and it helps user to keep track of all the running processes in the system with their memory utilization. it directly deals with the memory consumption by each process. The aim of this product is to prevent memory overflow problems. To prevent the memory overflow problem, it allows user to set the threshold value for each process in terms of memory utilization, so that whenever a process basically crosses its memory threshold, then this tool will terminate the process and acknowledge a user by providing alert box and an email notification. So basically this tool provides a configuration file where user can set the threshold value for each processes and provide an email address in which user will get the notification about the terminated process by this tool, and the last one is scheduled time period. So as this process or product is basically pertains to memory management, so it should be a never ending process. So like whenever we deploy this tool in a server, so it should be a never ending. So that's why we provide a scheduled section in our configuration file, so that in every time period this tool will trigger again and again. So this is all about the overview of this product. So let's jump into the architecture of this. So here is our Procespy. Let's assume it is deployed on a particular server and we have a configuration file. So it basically fetch the configuration and performs its task from the configuration file, and fetch the basically process details from the system by using process state command, and then validate the memory consumed by process with the threshold value of that particular process present in the configuration file. Then if any process crosses its threshold value, then that process will be terminated by this tool by providing an alert box and send an email notification to that user by getting the email address from the configuration file. So this is whole about this product Procespy. So it is purely based on the Rust programming language. So now let's move to our next product, which is related to the networking area, the Prolance. Again, the word Prolance is a combination of two words, protocol and surveillance. As this is on networking area, so here we deal with the protocols. Here we have two set of protocols. So first let's discuss about the Prolance first. So Prolance is a tool that can monitor the protocols running on a particular server. It is majorly developed to keep track of all the activities of a particular protocol. For example, we have a server configured with number of protocols and we want to basically monitor all the activities running on a particular server. So to achieve this, we can basically achieve this scenario with the help of this product, which is Prolance. So as of now, we worked only with the two protocols. The first one is DHCP and the second one is Active Directory. So before jumping into the architecture part of this product, let's understand what DHCP is and what Active Directory is. So DHCP is a dynamic host configuration protocol. It is a network management protocol used on UDP/IP networks, and DHCP server dynamically assigns IP address and other network configuration parameters to each device on a network so that they can communicate with other IP addresses. We have four stages in the DHCP. The first one is DHCP discover, the second one is DHCP offer. Basically DHCP server is a client side request or a stage, or DHCP offer is a server to client, DHCP request is client to server, and the last one DHCP acknowledgement, it is server to client. So this is all about DHCP. Let's move to the next protocol, Active Directory. So it is basically a Microsoft product and is a directory service developed by Microsoft for Windows domain networks. So Active Directory consists of several services that run on Windows Server to manage permissions and access to networked resources. So this is all about the Active Directory and basically the DHCP. So let's move to the architecture. So before jumping into the architecture part, let me tell you, this product is also based on configuration mechanism as we have in the Procespy. However, the only difference is here we are working with the protocols logs generated by protocols basically on the server, particular server. So, and in the configuration file, the user will provide the log details, like if I want to get the logs of a particular section, like in the DHCP we have 4 sections and I want only the logs for 2 sections. So I will configure that detail on the configuration file and put a filter flag to true. It means like I want the filtered log. So basically this is the detail about the configuration file. So as you can see here in the architecture, we have Windows Server 2012. As we are working with Active Directory, that's why we have used the Windows Server. So we have configured both the protocols DHCP and Active Directory in the server. So the flow goes like this: product will fetch the logs from the basically server corresponding to both the processes, and if user wants any filter, then this will perform filtration mechanism, and if not, then this will directly work with the raw logs and then produce the compiled logs into the Kafka topic, whether the filtered log or raw log. But to make the transition faster, we have provided a compression mechanism as well. So before publishing to Kafka topic, this tool will compress the compiled logs and then send to Kafka topic. So this is all about the basically architecture of Prolance. Now let's move to our embedded area, where we have 2 products. First one is Hawk. Let's talk about this one first, then we will move to the second product, which is actually a extension of Hawk. And before proceeding to the next product, we this is the technology stack of Prolance. The first one is Rust programming language. The second one is Apache Kafka, we have used for message queuing, and the Windows Server. So Hawk is basically an image recognition project. So the goal of Hawk is to create a security system which uses some AWS services. It is based on two-way factor authentication process. So basically we used Raspberry Pi and its camera to develop this product. And to understand this product, so let's take a scenario like whenever a user tries to enter the organization's premises basically, then he has to verify his identity before entering the premises. Basically our product is purely based on that verification process, and this will be installed at the entrance of the premises. So if a user wants to enter in the premises, then he has to scan his or her RFID card to the RFID scanner, and after scanning the RFID card on the RFID card, our product will capture the user's image who provided the RFID to make sure that he is the owner of RFID card, because an unauthorized user can also enter the premises by having a RFID of an authorized user. So this is how we achieve the two-factor authentication process. So let's move to the architecture of Hawk. So here we have two S3 buckets. The first one, these are the S3 buckets. The first one is for clicked images. It will store the clicked image of a user, and the second one, which is for reference image, it has images of all the employees with the name of their employee ID. So let's start with the flow. The flow goes from here. So initially the user will scan his or her RFID card to the RFID scanner, and then this scanner will fetch the employee ID from it, and so our product will capture the image of that employee and send the clicked image along with the employee ID to the AWS Lambda, this one. Here we perform the computation, and concurrently we store the clicked image to the clicked image bucket, which is situated here. right? So then the lambda extracts the reference image from the reference bucket with the help of employee ID, and then send both the reference image and the clicked image to the AWS recognition. Then recognition will return the similarity score of both the images to lambda, and lambda will pass on the similarity score to the Raspberry Pi. After getting the similarity score from the lambda, our Raspberry Pi will check whether the similarity score is greater than 80% or not. If the similarity score is greater than 80%, then user will able to enter in the premises, otherwise not. So this is the idea behind Hawk. The technology stack we have used in the Hawk is Rust programming language, AWS Lambda for computation, Docker for containerization, Amazon S3 for storing the clicked and reference images, Amazon recognition for getting the similarity score of both the images, and the last one is HashiCorp Terraform. It is used for setting up the basically infrastructure in the AWS environment. So now let's talk about our last product, which is Conf-Count. So it is a conference monitoring system, and it is an extension of Hawk, and the major goal is to create a monitoring system for conferences. So let's take a scenario where we scheduled a conference and we want a product that can monitor the attendees of the conference, like how many attendees, how many actually registered candidate actually joined the conference. So let's understand this scenario with its architecture. So basically, initially user will register itself for a conference along with his or her image. Then this product will store the detail of the user in the database and store the image into S3 bucket. Then there is a admin panel as well, which perform all the admin kind of stuffs, like he or she can delete, update or add any conferences and manages the users as well. So basically the flow goes like, here we have our Conf-Count situated at the conference. So at the time of conference, so in between our camera, Raspberry Pi's camera will trigger by this Conf-Count, and then after clicking the group image of all the attendees, Conf-Count will send the conference image to the recognition. Then recognition fetch users images, basically all the registered users images from the S3 bucket, and will perform the computation of basically matching the images. So after matching or comparing all the images, this will return a similarity score of all the users to the Conf-Count, right? Then if a user is present in the conference, then that's fine, right? But if not, then the Conf-Count will send an email to that user, basically which is not present in the conference, with all the details related to the conference, like the slides, the content, and the all major details to that employee, so that he or she can update it with the conference. So this is all about the Conf-Count architecture. So this is how we can achieve the basically a product which can monitor conference by itself. So the tech stack is basically a similar to Hawk, but we have incorporated another tool basically in the form of DB, the MongoDB, which stores all the basic details of registered users. So this is all about the products which we have covered, or which we build with the help of Rust programming language in the areas of command line interface, networking, and embedded. So let's move to the more from Knoldus. So in Knoldus we have innovation labs, we have blogs, we basically consistently blogging and share our knowledge and research. We basically consistently perform some basically do open source contribution to the communities and provide KT sessions related to all the latest technologies. And we have a product called TechHub as well, which contains all the learning templates and accelerators. So at the last, we are introducing our new, basically a new newsletter for Rust programming language, which is Rust Times. So it provides all the latest articles, jobs, events and releases. So if you want to get updated with all the latest news of Rust programming language related to jobs, events, releases and articles as well, so please subscribe to this to get updated. So this is all about our products, basically our agenda of this session. So thank you all.